Have you ever stopped to think that what seems to be common can, in fact, hide unimaginable secrets? In a world where everything moves fast, the wind seems simple, doesn't it? But what if I told you that the wind holds a secret that can change the way we see the world? What if I told you he has a secret life that few people know about? Get ready for a journey where theory, mystery, and science collide in a story that could transform everything you know about wind and the planet. The wind theory that can change the world. Edmond Halley's theory that will surprise you. Edmond Halley, whose name resurfaces in astronomy books due to the discovery of the comet that bears his surname, didn't limit himself to simply gazing at the stars. His attentive gaze on nature wasn't restricted to space, but also extended to phenomena occurring here on Earth. While Halley was already a great pioneer in astronomical science, his curiosity led him to question the workings of natural processes that, until then, had seemed simple and obvious, at a time when understanding of natural phenomena was still in its infancy. Halley proposed a theory that, at first glance, seemed like just another scientific hypothesis. However, his insights into wind and weather would go deeper than any observation made up to that point. For Halley, wind was not a chaotic, directionless movement. He believed that wind was an intelligent force with cyclical behavior and, surprisingly, with a fundamental purpose in the balance of the Earth. Halley suggested that the wind didn't move randomly as if governed solely by air pressure and temperature differences. In his view, it behaved in an orderly fashion, following cycles intimately linked to climate and the rhythms of nature. He saw wind not only as a means of transporting air, but as a key to understanding how the planet balanced itself. This theory suggested that wind had an invisible but powerful influence on Earth's environment. Its movement wasn't just a consequence of atmospheric dynamics. It could play a fundamental role in how weather manifests itself and how the seasons alternate. Halley believed that wind, with its circulation and cyclical patterns, was a missing link in understanding global climate and how the planet maintains its balance. What Halley saw was an invisible web of forces connecting all aspects of nature. This web, the movement of the wind, interacted with the oceans, air masses, and even the Earth itself, in ways he believed even the science of the time couldn't grasp. What appeared to be a simple exchange of air between different points on the planet could, in reality, be an essential component of the functioning of our global ecosystem. This insight challenged the belief that wind was merely a sporadic phenomenon. Halley suggested that it had a profound but secret impact on ocean currents, sea temperatures, and even the climate changes humans experience on their lands. But what Halley couldn't have foreseen was how much his theory would become a milestone in our current understanding of winds and their influence on climate phenomena. While we haven't explored all the details of Halley's theory, it helped lay the foundation for much modern climate research. He was one of the first to suggest that wind had a purpose beyond what meets the eye, and his ideas continue to resonate today as scientists seek to better understand how wind influences our planet and the climate change we are experiencing. Halley bequeathed us the idea that wind, far from being merely a passing breeze or a strong wind, is a force with a more complex and essential role. His insight that it could have cyclical behavior and a secret influence still provokes and challenges us to look more deeply into the natural forces that govern the Earth. Halley went beyond simply observing air movement, a seemingly simple reaction to the sun's heat. He began to realize that wind wasn't just a direct response to differences in temperature or atmospheric pressure. In fact, Halley suggested that wind followed a much more complex cycle, something that continues to defy our complete understanding. In his view, wind wasn't just a sporadic phenomenon. It had its own pattern and played a vital role in Earth's dynamics. Halley proposed that the wind functioned as an invisible network, connecting every point on the planet in a way that transcended the simple movement of air between high and low pressure areas. In his mind, the wind wasn't just moving from one location to another without purpose, but in some sense behaved like an interconnected organism whose air currents connected continents, oceans, and atmospheric regions. This complex network was not visible to the eye, but its impact was profound. It connected every aspect of nature, from the oceans to the great land masses, creating a dynamic balance that Halley intuited was essential for maintaining life and climate on the planet. Imagining wind as more than just moving air, Halley invites us to think of each air current as an invisible river. He suggested that these wind currents could be far more powerful than we realize, influencing the climate in significant ways. For example, wind can affect the temperature of different regions, helping to distribute heat around the planet and controlling weather conditions in various areas. When these invisible rivers move from one region to another, they can transport vast amounts of energy, altering the climate and even causing abrupt changes. Furthermore, Halley believed that this network of winds played a vital role in the Earth's balance. He suggested that air movement was not only a consequence of climate, but also a key driver of its regulation. Wind dynamics affected the distribution of heat and moisture, directly impacting phenomena such as storms, droughts, and even the flow of ocean currents. Halley proposed that wind acts as a kind of connector between Earth's various natural systems, organizing and balancing our ecosystem in ways we still don't fully understand. This theory went beyond simple air movement. Halley was pointing to a global network of complex interactions, where wind was not a simple reaction, but a fundamental link in a larger system that regulated climate and environmental conditions. He believed that wind currents could even influence catastrophic weather events, such as storms and prolonged droughts, and that understanding this wind network would be crucial to predicting these phenomena and maintaining the planet as balance. Today, with advances in meteorology and climatology, we can observe the impact of this invisible network of wind, especially with regard to the phenomenon of jet streams, which play a fundamental role in climate change and the transport of energy around the planet. But in his time, Halley already intuited that wind was much more than a simple movement of air. It was an interconnected force essential to the Earth's balance, something that, to this day, continues to fascinate scientists and researchers worldwide. What if wind played an even deeper role than we've always imagined? What if it were more than just a means of transporting air, moving aimlessly to create the weather we experience? What Halley intuited, and what his observations led us to believe, is that wind might be intrinsically connected to much larger and more complex forces. He suggested that wind, far from being merely a flow of air controlled by temperature variations, had a secret function, almost like an invisible cog within a larger system involving the oceans, the climate, and even life on Earth. But how could this be possible? Halley believed that wind was not an isolated element. For him, it was part of a much larger and interconnected network, an invisible web that connected Earth's diverse systems in mysterious and powerful ways. What he suggested, and what science today is beginning to understand more concretely, is that wind has a profound impact on the movement of ocean currents, the behavior of the oceans, and therefore, global climate patterns. Let's imagine, for a moment, what this would mean. If wind is capable of influencing ocean currents, this would have direct implications for the distribution of heat around the planet, the exchange of moisture between the oceans and the atmosphere, and the formation of the large air masses that determine the climates of different regions. Wind would then be a force that directly connects the oceans to the atmosphere, and consequently, to Earth's climate. Halley was suggesting, almost visionarily, that wind behavior could hold the key to understanding some of the greatest climate phenomena humanity still struggles to grasp. He believed that wind, with its invisible network of currents and movements, could be the driving force behind extreme and periodic weather events such as El Niño, monsoons, and even the seasonal changes that mark our seasons. El Niño, for example, is a climate phenomenon that alters ocean currents and brings enormous amounts of heat to areas of the Pacific, affecting the global climate with such intensity that it can result in droughts and floods in several regions. Monsoons, in turn, are seasonal changes in winds that cause torrential rains during certain periods of the year, with direct impacts on agriculture and water supplies in Asian countries. As Halley imagined, these changes in climate and atmospheric conditions could be directly linked to wind behavior, with their currents altering ocean conditions and, consequently, global weather patterns. Furthermore, the way wind influences the atmosphere and oceans can help explain climate fluctuations over the years and even the seasonal changes we experience. Wind movement in the upper layers of the atmosphere, known as jet streams, may be responsible for guiding weather systems around the world, creating or dissipating areas of high and low pressure, and modifying the weather in different regions. Therefore, Halley's theory leads us to consider how wind, with its invisible network of movements and cycles, is more than just an atmospheric phenomenon. It is a fundamental link connecting the oceans, the climate, and living beings themselves. This system, which Halley believed had a secret function, may hold the key to understanding our planet's complex and often unpredictable weather patterns. Halley was, in essence, proposing that wind was an invisible but immensely complex force that could explain Earth's greatest climate challenges. Today, science is beginning to unravel these connections, and the wind network Halley envisioned is proving increasingly vital to our understanding of the global climate and its changing conditions. Today, with technological advances, we have the ability to understand wind in far greater detail than Halley could have imagined in his time. Using satellites, atmospheric sensors, and complex climate models, scientists have mapped the movement of winds around the planet with impressive precision. This data allows us to observe how air currents form, move, and interact with Earth's different climate systems. In a sense, Halley's ideas were only scratching the surface of a much more complex phenomenon. Halley, in his time, suggested that wind played a fundamental role in Earth's dynamics, but what he couldn't foresee was the magnitude of wind's influence on our climate. Today, we know that wind is a key force not only in temperature changes, but also in controlling ocean currents, storm formation, moisture transport, and regulating global weather patterns. Winds, in essence, are the heartbeat of Earth's climate system, transporting heat, moisture, and energy across the planet. However, even with all the knowledge acquired, there is still much to discover about the hidden power of winds. They not only regulate the weather in local areas, but are also fundamental to the formation of large weather systems such as tropical cyclones and jet streams. Wind may be a determining factor in the climate changes we are witnessing today, exacerbating or moderating phenomena such as global warming and rising ocean temperatures. Could Halley have sensed, with his foresight, that winds would actually be a much greater force than he imagined? One of the greatest modern discoveries was the understanding of how winds interact with the oceans, creating what are known as ocean currents. These currents are fundamental to the redistribution of heat around the planet, transporting warm water from tropical zones to polar regions, and cold water from polar regions to tropical zones. This not only affects local climate, but also has a direct impact on global weather patterns such as the El Niño phenomenon, which alters weather conditions across much of the world. Furthermore, winds are crucial in the formation and intensification of storms. Cyclones and hurricanes, for example, depend on the interaction between wind currents and warm ocean waters to form and gain strength. The wind dynamics surrounding these weather systems can intensify or weaken the storm, making predicting and controlling the behavior of these weather events challenging, even with the most advanced technologies. But the mystery of wind goes beyond storm forecasting. Scientists are only beginning to understand how high-altitude winds, such as jet streams, influence global weather patterns. These fast-moving air currents, located in the upper troposphere, play a key role in controlling the weather in various regions of the planet. They are responsible for guiding atmospheric pressure systems, which, in turn, affect the climate on a large scale, causing droughts, heavy rainfall, and seasonal changes. Therefore, while modern science has made considerable progress in mapping and understanding wind movement, there are still many mysteries to be unraveled. What exactly the wind knows and how it acts on a global scale remains a fascinating question. Halley's theory, with its idea of an invisible network connecting Earth's natural systems, remains relevant today as scientists and climatologists seek to understand how these hidden forces, which Halley studied so extensively, shape our world in ways we are still beginning to comprehend. And based on what we know now, it's possible that Halley somehow sensed the complexity of what was to come. His insight that wind is not just a simple phenomenon, but rather a connective force vital to the Earth's balance, seems increasingly accurate as we explore further the secret life of wind. The future of climate science may be closer than we think if we can understand Edmond Halley's theory more deeply we could usher in a new era of climate prediction and control. Halley, with his pioneering vision, suggested that wind played a hidden role in the Earth's functioning, interconnecting various natural systems. Today, as technology and climate modeling advance, we are beginning to realize that this idea may hold the key to predicting and even mitigating natural disasters that were previously unpredictable and devastating. The study of wind is not limited to its role in air movement and local climate, but we increasingly recognize that it is a central force in the formation of extreme weather. Phenomena such as hurricanes, cyclones, and tropical storms. These devastating events are caused by the interaction of warm and cold air, currents, and by how wind affects the dynamics of ocean waters. The power of a storm, for example, depends on wind conditions, which determine its intensity and path. With a more accurate understanding of winds, we can predict these storms earlier, saving lives and mitigating damage. But perhaps more importantly, we can even learn to influence or control these winds in critical situations. Imagine a future where we can use technologies to alter wind patterns in specific areas, such as mitigating a hurricane's strength or diverting its path to avoid densely populated areas. It sounds like science fiction, but with advances in research in geoengineering and climate modeling, these ideas are becoming increasingly plausible. Furthermore, winds play a central role in controlling climate on a large scale. They regulate ocean temperatures, the flow of ocean currents, and the distribution of moisture around the planet. As climate change continues to alter these natural patterns, understanding wind can help us understand how these changes will affect different regions of the Earth. This allows us to anticipate prolonged droughts, floods, and other extreme weather conditions, giving us time to prepare and take preventative measures. We're closer than ever to understanding wind behavior. Tools like satellites, advanced climate models, and supercomputers are already allowing us to map winds on a global scale and analyze how they interact with other Earth systems. This gives us the ability to observe not only air currents at a local level, but also how they affect climate behavior globally. With this growing understanding, we can envision a future in which wind, which has always been an invisible and unpredictable force, becomes an ally in the fight against climate change. What Halley saw as a mystery of wind may one day hold the key to solving the most challenging climate problems of our time. And who knows, what seemed like a simple, invisible, natural phenomenon may one day prove to be the vital force in saving our planet from imminent climate collapse. The impact of winds in the future may be far greater than we imagine today. With the right knowledge and technology, we can not only predict and mitigate natural disasters, but also learn to control wind in a way that helps us restore balance to our climate. Just as Halley anticipated nature's invisible interconnections, the future may show us that wind is, in fact, one of humanity's greatest allies in the fight against climate change. The wind has always been a constant presence in our lives. It's there every day, touching our skin, moving the leaves on the trees, and shaping the weather around us. But what do we really know about it? The truth is, no matter how familiar the wind may seem to us, it still holds many secrets that, to this day, continue to fascinate scientists and curious people around the world. Edmond Halley's theory, though proposed centuries ago, still resonates in contemporary scientific thought as a starting point for exploring the hidden power of the wind. Halley, with his foresight, already suggested that wind had a much deeper function than simply moving air from one place to another. He believed that wind had a secret life, a cyclical behavior interconnected with Earth's natural systems. And even though today's scientific advances allow us to map and observe winds in greater detail, Halley's idea that wind plays a vital, hidden role still resonates powerfully. What if, somehow, wind held the key to understanding our world in a completely new way? Wind, with its invisible movement and profound impact on climate, oceans, and even seasonal changes, could be a fundamental element in understanding the Earth's balance. Perhaps, by deepening our understanding of wind and its dynamics, we can unravel its mysteries and ultimately understand how it shapes our reality in ways we never imagined. Halley invited us to view wind not simply as a natural phenomenon, but as an interconnected force affecting every aspect of Earth. He suggested that behind this invisible force lay a complex system, that we are still trying to decipher. And today, more than ever, with advances in technology and climate science, we are closer to understanding the true nature of wind and how it influences the world around us. Perhaps, with Halley's theory, we can finally understand the secret life of wind and how it fits into the grand mosaic of nature. After all, what seemed like just a passing breeze or a distant storm could be the key to unlocking our planet's secrets and, who knows, finding solutions to the climate challenges we face. The wind has more to teach us than we imagine, and perhaps it is from this invisible force that we will find the answers to many of the mysteries surrounding our existence and the future of Earth. As Halley sensed, the wind may indeed be one of the greatest forces of nature that we have yet to fully understand.